3-terminal operation. Just only connects source and M pin to ground, control pin to the optocoupler, and it will drive the transformer. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Hasim Electronics. I received this message from one of my viewers. He asked me to make video on TOP243. Make a video with full details and other comment from the same viewer. TOP243 YN को लेके कुछ कहिए sir please. He asked me to say something about TOP243 YN. Then there is another comment from one of my viewer. Please explain IC TOP250Y. So I have 3 requests for this video. So let's discuss. TOP242 to TOP250, it is one family. It is tiny switch 2 family, enhanced energy efficient low power offline switcher. It is basically offline switcher. Very simple and very useful IC. First of all, the circuit receives AC voltage, rectifies it, and these voltages are applied to this bulk capacitor, this TOPSwitch-GX. It have few components. So this IC will receive voltage and it will drive the transformer. SMPS transformer, high frequency transformer, will induct voltage in its secondary. The voltage will rectify it and we will take output. And we have another control winding, bias winding or auxiliary winding. We can say VCC winding. So these voltage are rectified and these voltage are passed through the optocoupler to the control pin. Basically the top switch 242 to 250. This is a set of ICs. It have different packages: P package, G package, R package, Y package and F package. If we see 242, it have 5 package: P, G, R, Y and F. 243, these all ICs are same: 240, 243, 244, 45 and 46. These are the same: 247, 248, 249, 250. These are the same. Just there is a difference from 242 to 246 are in P and G package. 47 to 250 are just only R, Y and F package. All ICs have the same model numbers R, Y and F, but 242 to 246 are P and G additional. What are the packages? P package is plastic dip dual and line package, and G package is SMD. This 8 pin IC, but pin number 6 is missing, so it have 8, 7, 5, 1, 2, 3, 4, and this IC will come in dip and SMD. If suffix is 242P, that means plastic and dip package. If there is a G, that means it will in SMD package. If it have R package, it is TO2637C. It will in this shape. If we have Y, so Y is here. R and F package are approximately the same. If we have 242P, that means plastic, that is 9 watt. If we have SMD, that is 9 watt. In 230 volt plus minus 15%. 230 volt operation, it is approximately 290 volt to 265 volt. In 230 volt plus minus 15%, this IC will deliver output power 9 watt. In open frame condition, it will give 15 watt. So 242 PRG package will give 9 to 15 watt. If it is R package, these are heatsink mounted, 15 watt and 22 watt. Y and F package, this package and this package. If it is R package, the suffix is R, that means that will 15 watt. The same IC, but the part number, the suffix number P, G, R and Y will determine the power value. In open frame package, it will give 22 watt. This is the design in adapter casing or in open frame casing. This design is 230 nominal plus minus 15, that means 285 or 290 to 265. but this is in wide range. This is universal and this one is in tight calculation. So in universal calculation it will give 6.5 watt, in open frame 10 watt. So here we can see 9 watt, and in universal power supply it will deliver 6.5 watt. Now 243, the first IC is 9 watt, the second is 13 watt. 244 16 watt, 19 watt, 21 watt, 42 watt, 43 watt, 44, 45 watt. This 243, 242, 244, it will determine the family number and it will also give us the rating of the power. If we have an IC in a board, for example 242P, that is 9 watt, we can use 246P, that will work in the same condition. But if we have 246 and we cannot find 246 in the market, so we cannot use 242. But if we have 242 bad IC in the board, so we can use 243, 244, 245, 246. We can use any one next upper number, so that IC will work. But we cannot replace any IC with the lower number. For example 249Y, so we cannot install 242Y instead of this IC. P and G package, the pin number 1 is multifunction pin. Pin number 2, 3, 7 and 8 are source pin, are ground pins. Pin number 4 is control pin. We can say it is a feedback pin. Pin number 5 is drain pin. So source, drain, control, multifunction. But if we see here, C for control, L for line, X is current limit, here is source, this is frequency, here is D for drain. Every pin have different configurations, although it have a few pins. So we have source, drain, control and multifunction. So multifunction, it have many options. It can be used in different ways. Control pin can be used in different ways. We can follow this table to determine the power. Top 250 can deliver power from 135 watt to 290 watt in open frame. In adapter case, we can use 135 watt. To design universal power supply, it will deliver 90 watt to 210 watts. The part number, the first top, that is top switch product family. Then we have 242, that is GX serial number of the IC. From here top 242, then P, G or any suffix. G is plastic assembly, P is plastic dip, Y is plastic TO227C, R is plastic TO263 7C, available only with TL option. Then we have F, that means plastic 262 7C. Then we have N, that is lead finish. If there is blank, that means it is standard, it's pin finishing with lead. And if there is N, that means it is lead free. P, G, Y and F packages. Then we have TL, tape and reel and other options. If there is blank, that means it is in standard configuration. Lower system cost, because it is using few components, so its design is very simple. Extended power range for high power applications, because it have built-in MOSFET and it can drive high power loads comparing to other SMPS controllers. No heatsink required up to 34 watt using PRG package. The best benefit of using these ICs, this family, it is cost effective because it is using very minimum external components. It have built-in soft start and it can be programmed externally by limiting accurate current limits. It have a current sense pin and we can limit the current by setting a resistor value to the X pin, to the current limit pin. So it cannot just the duty cycle for more power by using smaller input capacitor at input side. Built-in undervoltage detection circuit. So it will detect the undervoltage and overvoltage, and it will prevent the circuit from EMI and RFI DCMAX option. It will adjust its duty cycle and it will reject the line ripples. It will limit the DCMAX maximum duty cycle at high line voltage. It have frequency jittering and it will reduce EMI electromagnetic induction. So that will cause to reduce EMI filter cost. Regulate to zero load without dummy loading. As we know, when a circuit is designed for any SMPS controller, any SMPS controller needs a dummy load. For example, I am designing a circuit for 50 watt. We need a minimum load to keep running the IC PWM controller. For example, 2 watt, 3 watt. We have to put a dummy load resistor in the output side to maintain the regulation. But this IC does not need any dummy load. It will regulate the output without any dummy load. So its switching frequency is 132 kHz nominal. As we know, when the frequency is high, the switching frequency is high, so that will reduce the magnetic design and the converter size. The dissipation power will reduce. In Y, R and F packages, a half frequency option in Y, R and F package, because that is frequency pin. If that pin is controlled, so it will switch the frequency to 66 kHz. Normally it will work at 132 kHz. In that case, its frequency will drop to 66 kHz. So this IC have built-in thermal shutdown and automatic fault recovery. It have extremely low consumption in remote off mode. It have a remote off mode, and if we are using at 110 volt, so it will dissipate only 80 milliwatt and 160 milliwatt at 230 volt AC. It is cost effective. It have a built-in MOSFET. It have a protection circuit. It have a control circuitry. All these features are embedded in just only one chip. Now here we can see the block diagram of the IC. This IC it have control pin, external current limit, X pin, line sense, L pin, and frequency setting, F pin. We have a drive section, that is source and drain. Source is connected to negative end of the bulk capacitor. It will pass through this MOSFET. Then we have a point here. Here is a current limit comparator. Then we have drain. This drain is connected to the SMPS transformer. The same point, it will take a voltage for chip biasing to generating a reference. This ground level will switch to the SMPS transformer. The second end of SMPS transformer is connected to positive terminal of the capacitor. So current will pass from this point here, transformer, and to the positive terminal. So it will cause to induce magnetic field. So this IC will take chip IC voltage from this point, positive voltage, and these voltage are applied to the chip to activate the circuit. In first step, this IC will make a soft start. When the output level will maintain, at that time it will take a feedback signal. It will take a VCC voltage, control voltage, to this comparator. This IC will adjust its duty cycle to regulate the voltage. Here we have external current limits. So this external current limit will cause to adjust to output current. Here we take a reference for our required current, and from this point it will monitor the flowing current. At this point we make a limit how much current we need. When this current will increase from the required limit, this comparator will directly switch to this AND gate and it will control the switching through this loop. Line sense voltage, it is to monitor the under voltage and over voltage. For example, we adjust here a resistor and apply voltage at this point, so it will monitor the level of voltage. For example, most of the time For universal power supplies, it is designed from 100 volt DC to 375 volt, 400 volt DC. It will monitor the voltage at this point. Then we have F frequency. Frequency, when this pin is connected to frequency, ground pin, it will work at 132 kilohertz. When this pin will connect it to control pin, it will work in half frequency mode. Here is steric thermal shutdown. If there is over temperature or anything, it will switch this NOR gate and it will stop the switching of this MOSFET. This block diagram is for Y, R and F package, because Y, R and F package have control pin, X pin, L pin, frequency pin. But the P or G package, it have only control pin and multifunction. M pin will work same as X, L pin. F pin is not available in this circuit. It will just work only at 132 kilohertz. Here we have shunt regulator. When it will receive voltage from control pin, it will make a reference. It have a positive reference at non-inverting input, and feedback voltage are applied internally to this operational amplifier inverting input, so it will adjust the reference to this RE emitter resistance, and it will change the drop voltage at this operational amplifier, so that PWM comparator will compare the input voltage and our generated signal for PWM signal. Half frequency is not available here in this P and G package. Positive voltage are applied here through 2 mega ohm resistor at L pin, line sense pin. X pin, current control pin, is connected to ground, and S pin, source pin, is connected to ground. Then the drain pin is connected to transformer. The drain pin, D pin, the first one pin, is connected drain output. Internal startup voltage and VCC chip voltage are connected to this pin. So this chip will take its VCC voltage, startup voltage from this pin, and internal current limit sense is also connected at this pin. Here is internal current limit, and here is VCC voltage, startup voltage, soft start voltage. When there is no control voltage, so that time these voltage will reach here and it will start up. Control pin is feedback pin for adjusting duty cycle. It is connected to VCC winding through optocoupler. So optocoupler will control the voltage reaching at this point. So this IC will know that the output voltage are reached at required limit. Then there is line sense, L pin, Y, R and F packages only. So line sense pin is used for overvoltage, undervoltage, and it is also used for line feed forward with DCMAX reduction. In duty cycle, maximum duty cycle reduction, remote on off and synchronizations are also programmed from this pin. And if we connect this pin to ground, so it will disable its all functions. Then we have external current limit pin, I under voltage multiplied by RLS. This is the value of RLS. So that time we will determine the under voltage, how much current and how much is resistance. Then we have VOV, over voltage current multiplied by RLS. So it will determine the level of voltage. If we connect 2 mega ohm resistor for RLS 2 mega ohm, VUV under voltage 100 volt DC, over voltage 450 volt DC. So under voltage and over voltage window is defined by this resistor. Then we have DCMAX at 100 volt. This IC will switch at 78%, 375 volt DC. It will switch at 38%. So duty cycle will also calculated from here. For current limit resistor 12K, the current will be limited at 69%. See figure 54B for other resistor values. So you have to go to 54B for selection of different value and limiting the current. This X pin is available in Y, R and F packages. Then there is M pin, multifunction pin, the same L and M pin. Same function, L and M This pin combines different functions like line sense, external current limit. External current limit is basically available in separate pin is available Y, R and F packages, and P and G, 8 pin DIP and 8 pin SMD don't have X pin here. So under voltage, over voltage, current limit, all functions will adjusted from here, and if this pin is connected to ground, it will disable all functions and it will just start at 132 kilohertz directly. So here is a current limiting for RIL. If we use P and G package, here we limit current for Y, R and F package. We have X pin, but here we don't have X pin, and if you want to control the current, so M pin will connect it to the ground RIL. That is resistor current limiting. If you connect the same 12K resistor at M pin, so it will limit the current at 69%. If you connect 25 kilo ohm, it will reduce the current at 43%. F pin, frequency pin for Y, R and F packages. If you connect that pin to ground, that IC will work 132 kilohertz. If the F pin is connected to VCC voltage, the control pin, so that IC will limit its switching frequency at 66 kHz. That is called half frequency operation. The switching frequency is internally set for fixed 132 kHz operation in P and G package. As I discussed earlier, that Y, R and F packages are working at two frequencies, 132 and 66 kHz, but P and G are initially set at 132 kHz operation. Then we have source pin. The source pin is ground pin. It is power ground, and it also provides the chip biasing voltage ground to the IC. Here we have full frequency operation. When we connect this pin to ground, so this IC will work at 132 kHz. And if we connect this F pin to control pin, at that time this IC will limit its switching at 66 kHz. So half frequency operation in standby mode, normally 20 kilo resistor, and there is a switching transistor. If we want to switch this IC from half frequency, so when this switch will on, this transistor will on, it will switch voltage to F pin. And here is three terminal operation. If you disable everything and you want to work this IC as a standalone chip, so this IC will work at 132 kHz directly. Just only we have to connect control pin, source, X pin, current limit pin and frequency pin to ground, L pin to ground, pin D2 to drive the SMPS transformer. So our circuit will work as a three-terminal operation. Line sensing under voltage, over voltage and line feed forward. When we connect, as we discussed, when we connect this resistor, it will adjust for 2 mega ohm. It will adjust this IC to work in this window at 100 volt and 450 volt. From 100 to 450 volt, this IC will work, and it will adjust at 100 volt. It will adjust its duty cycle at 78%, and maximum 375 volt it will adjust its duty cycle at 38%. Then we have line sensing for under voltage only. It will maintain under voltage. If you connect 2 mega ohm, 22 kilo ohm, 6.2 volt zener to ground line, so in this case over voltage option will disabled. And if you want to disable the under voltage option and this IC, we have to work for just only over voltage protection. So that time one diode is here connected and 30 kilo ohm resistor with 2 mega ohm resistor. So this configuration will disable under voltage sensing. It will just only work as over voltage. External current limiting. If you connect 12 kilo ohm resistor, so this IC will limit 69% current, and at 25 kilo ohm resistor, this IC will limit the current at 43%. So this resistor can be adjusted at any value. How much current we want to control in the output section, So this resistor will allow to control the current limit amplifier. So here is current limit reduction with line voltage. So here is active on failsafe circuit configuration. So it can be configured in this way. Here we have active off, remote on. Here we have active on, remote on off with external set current limit. Here active off, remote on off with line sense. Active remote on off with line sense and external current limits. For active remote on off operation, this IC can be configured in this shape. P and G package. 3-terminal operation, just only connects source and M pin to ground, control pin to the optocoupler, and it will drive the transformer. It is very simple. There is no frequency adjustment, there is no RTCT and anything. Just only directly connect the VCC voltage here, D pin to the transformer, source pin to ground, and this IC will start switching. So here are maximum allowable voltage. Drain pin can work from -0.3 volt to 700 volts. So this IC can work at a wide range of voltage. Drain peak current at for 242 IC we can use 0.72 ampere. 243 TOP243 1.44 ampere. If we discuss TOP250, so it can switch at 10 ampere. Control voltage 0.3 volt to 9 volt. Its switching frequency average typical is 132 kHz and it can drive up to 124 to 140 kHz. For 60 kHz operation, the nominal frequency is 60, but it can vary from 61 to 70 kHz. So here we can adjust the current limit in ampere. How much ampere we want to limit, so we can adjust the current here. So friends, I hope so this video is informative for you. If it is informative, give a thumb up. If you have not subscribed my channel, subscribe it, and if you want to watch my future videos, you can press the bell icon button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.